Hey everybody, this video is for assignment 10, which is it's like a review. So there's two things that are going on here. One, we're going to go over the conditions because you're going to need to do those. The second one is we're going to learn a t-test, all right? So here in black, you guys see it says don't copy this. In black, I've written out what the conditions are, and in red, I'm putting like how you would answer the question based on this example. This is review. You've already learned this. Okay, condition one is that the sample must be random. So you want to go to the problem and see where it talks about the sample and find out if it's random. Right here it says the students will select a random sample of size 100. So the part in red is what you would actually write. You would say the sample was taken randomly because the problem states so, or something like that, because it does say that the sample was random. Condition two, if you recall, is that the sample must be less than 10% of your population. The important one for this one is just make sure it's in context. So it says the sample was size 100, but right here it doesn't tell you what the sample is. Like, is it cows? Is it corn? Is it people? Is it bears? Like, you need to know what the sample is. So in this case, they're talking about the average cost of textbooks. So that would be what your sample is about. So I'm going to say 100 textbooks is certainly less than 10% of all college textbooks in existence. So the population would be all college textbooks that exist, okay? The third condition, there are two of them. If it's a mean, then your C3 will be n must be greater than or equal to 30. If the question's a proportion question, then you have these two, NP and NQ must be greater than or equal to 10. So this problem, because right here, if you guys notice, it says the word average. It's talking about average cost. So this is a mean question. So all we have to do for C3 is prove that your sample size, which is 100, is greater than or equal to 30. So this would be what you would write on your paper for that one. If it asks you to do conditions, that's what it's asking for. Just to be clear, here's an example of one with the proportion. C1, you do the same thing. C2 is the same thing. C3 is the one that's different. You would have to do NP and NQ is greater than or equal to 10. So you guys would just plug in your N, which is in this problem, the SRS is 250. So that's N. And then for your P, P is the percentage of all US children. So P, remember, is about the whole population, whereas P hat is about the sample. So this number here would be P hat because it's about the 250 children, whereas this number here is about the whole population, 84. So I did 1 minus P to get Q. That's where I got the 0.16. And you would actually want to like multiply these out and just like check that it works. I didn't actually do that, but you should do that. Also, just make sure for C2 that you're really clear. So it's 250 children is definitely less than 10% of, it's not just all children. Be careful what you say here because this is talking about only children ages 8 to 18. So you should state that when you're talking about the whole population because that's what it is, okay? So you do need to do conditions on the first two questions of this assignment. You do not need to do it on the third. It says all that in the directions, so just read it. Okay, now we're on to a t-test. I would appreciate if you guys would copy this down into your notes. So if you could take a second, pause this, and copy this down, that would be great. Oops, I don't know what I just did there. I guess you can't see me anymore, but that's okay. So what we're doing here for the t-test is basically it's going to be the same like a z-test. The only thing is you're going to use a t-test when you're given S, because remember a z-test is for when you're given sigma. Okay, so you would start by doing the conditions. I'm skipping them because I just did two examples of that just a second ago. The next thing is you would do your two hypotheses. Normally, for you guys, you need to write them in words and in symbols. But right here, I'm just writing them in symbols to save time. So if the average IQ of all people, it's been known for years that that's actually equal to 100. So that's your HO. And then according to this problem, they want to test a new medication to see if it has a positive or a negative effect on intelligence. So because of that, because it says positive or negative, we're going to use a not equal to symbol for our HA. So basically all I've done here is I was given S because right here, when it talks about the standard deviation, if you guys can see right here, it's 20. It's referring to the sample. It says a sample of 30 participants has a mean of 110 and a standard deviation of 20. That means that this number is S, the standard deviation of the sample. So you would put that here. Your X bar is the mean of the sample mean, which is 110. Your overall mu is 100, and then your N is 30. So I put those in to get the standard deviation first. And then right here, you guys, if you notice, I circled the S and the T in yellow. It's because whenever you're doing S, you're actually going to need to use T here. Okay, so instead of Z, you're actually going to write T. It's still calculated using literally the exact same formula. So just use this same formula. It's just when you write it and when you draw it on your picture, you're going to use T. So in my drawing, what I've done is I first put this line here, the positive 2.74, and then I noticed I had a not equal to sign, which means you need to shade both tails. So I went ahead and put the negative version of the T score over here, and I shaded to both sides. Okay, this is the part where you're actually going to need your calculator, and I'm going to need to change this. I may have to start another video because I'm going to have to show you guys how to do this on the calculator. So you're going to need a calculator here. So go grab one. Okay, I think we're back recording here. Let's see. Yeah. So basically, what you're going to do now is take your calculator. I'm going to try and full screen myself. Hopefully that works so you guys can see. You need to go to the stat button, go over to test because we're doing tests right now. Then you're going to run a t-test because that's what we're learning. So go to t-test, enter. And by the way, you can use these other tests for the other material like that we've been doing. So you could do a z-test this way too to check your work. But I do want you to draw the picture and stuff. So guys, make sure that it says stats right here. If data is highlighted, that's no good. Make sure you're on the stats. Then enter all your information. That top one is mu. I don't know if you guys can tell, but that's a mu. You can ignore the 0. This one's obviously X bar. This one is S. S of X is the same as just S. Put in your N, and then right here goes your alternative hypothesis. So you just have to indicate which way the arrow is going. So like if your alternative had a greater than, then you would go with the last option. If your alternative had a less than, you would go with that middle one, but ours has a not equal to. Press calculate, and that's going to give you the p-value. So when it gives you the p-value, let me see if I can minimize this. When it gives you the p-value, it's actually giving you the entire region. So it already added them together for you, so you don't have to do that. So just write that down. It says 0.0104, and I'm going to compare that to alpha. It looks like 0.01 is less. Whenever p is less than alpha, you should reject HO. Remember, the smaller the p-value, the more likely you are to reject HO. Why is that? Because the smaller the p-value, the further your lines are from your mean. And if your lines are really far away from what they're claiming the mean is, then you're saying that that mean is probably wrong. Which means if you're disagreeing with this, you're going with this. You're saying that there's a lot of evidence to show that this is probably not true, because if it were true, these two lines would be a lot closer to the mean. If you're almost 3 standard deviations away, that's pretty far away from the mean. So we're going to say reject HO because p is less than alpha. There is enough evidence to conclude that you need to go back up and find what your HA is, so that the new medication has had either a positive or effect or negative effect on intelligence, or you could say there is enough evidence to conclude that the medication has affected intelligence. And that's it. So I'll be on tomorrow if you guys need any help with anything. I think that's it.